Hello, future engineers. Here are the continuation of Algebra 0, 1, and 3, 1 and 2 problems. So, if you want to anticipate the solutions to these problems, you may do so by pausing the video. So, problem 8, find the missing term from the series 2, 16 thirds, 7, 73 over 9, then blank. So, the technique usually is to get the difference between adjacent terms. I'll call that missing term as x. So 2 16 thirds, then 7 73 over 9, then x. Then the difference 16 thirds minus 2 is 10 thirds, 7 minus 16 thirds is 5 thirds, 73 over 9 minus 7 is 10 over 9. Seems to have a pattern. If we get the reciprocal, this is 3/10 or 0.3, this is 3/5 or 0.6, and this is 9 over 10 or 0.9. So if we obtain the reciprocals of these differences, we get arithmetic progression. Therefore, we conclude that these are in harmonic progression. So 0.3, 3/5, 0.6, so this is 0.9. So this is increasing by 0.3. Therefore, we expect that the next is 1.2. That's arithmetic progression. This is 1.2, and 1.2 is 6 over 5. Therefore, the fourth term of the difference between x and 73 over 9 is expected to be 5 over 6. And these terms are in harmonic progression. So let's deal with this arithmetic progression. So that is 5 over 6. Therefore, x is 73 over 9 plus 5 over 6. And that is equal to 161 over 18. Problem 9, if 1, 2, 7, and 20 respectively are added to the first four terms of an arithmetic progression, a geometric progression of four terms is obtained. Find the product of the first term and the common difference of the arithmetic progression. So for the terms in arithmetic progression, we have A1 plus D, second term, then A1 plus 2D, third term, and A1 plus 3D, the fourth term. As stated here, if we subtract 1, so we have A1 minus 1, that's in arithmetic progression. A1, if we add rather 1 to the first term of the arithmetic term, first term, then set 2 for the second, A1 plus D plus 2, then 7 for the third, A1 plus 2D plus 7, and for the fourth, A1 plus 3D plus 20. Then these terms would be in geometric progression. So the shortcut to this is the square of the middle term is equal to the product of the left and the right side terms. So quantity A1 plus D plus 2 quantity square equals quantity A1 plus 1 times quantity A1 plus 2D plus 7. Expanding, so we have to apply the technique in binomial expansions. So square of each term, then twice the product of these adjacent terms, twice the product of that, then twice the product of that. There are 6 terms here. So A1 square plus D square plus 4 plus A1D times 2, so 2A1D plus 4A1, then plus D times 2, 2D times 2, so 4D. Then we have A1 square equals A1 square. We have 2A1D and 2A1D, and so 2A1D. Then 7A1 plus 1A1, that would be 8A1. Then 2D plus 7. So we can cancel A1 square, 2A1D. Then simplifying, we have D square 4d minus 2d is 2d, so d square plus 2d, then 4a1 minus 8a1 is negative 4a1 equals 7 minus 4 equals 3. So d square plus 2d minus 4a1 equals 3. Call that equation 1. Likewise, we square this, and it is the product of the adjacent terms. So quantity a1 plus 2d plus 7 square equals quantity a1 plus d plus 2 closed times quantity a1 plus 3d plus 20. Expanding, we have a1 square plus 4d square plus 49 square of each term, then twice the product, plus 4a1d plus 14a1 and plus 2d times 7, 14 times 2, so 28d equals a1 square. Then we have 3a1d plus a1d, so 4a1d. Then 20a sub 1 plus 2a1 is 22a1. Then 3d square plus 3d square. Then we have 20d plus 6d plus 26d. Then finally plus 40. So combining like terms, we can cancel a1 square. Then 4d square minus 3d square is d square. You can also cancel for a1 and for a1d and for a1d. So we have d square, then 28d minus 26d is plus 2d. Then 14a1 minus 22a1 is minus 8a1. Then equals 40 minus 49, negative 9. So call that equation 2, d square plus 2d minus 8a1 equals negative 9. Then we substitute the value of d square plus 2d from equation 1, which is 4a1 plus 3 here. 4a1 plus 3 minus 8a1 equals negative 9. So negative 4a1 equals negative 9 minus 3, negative 12. So negative 4a1 equals negative 12. Dividing everything by negative 4. So a1 is negative 12 over negative 4, and that is 3. Having found a1 is 3, we then substitute into this equation 1 here the value of a1. So d square plus 2d minus 4 times 3 equals 3. So d square plus 2d, negative 12 minus 3, negative 15 equals 0. Then factor, we have d minus 3 and d plus 5 equals 0. So if d is negative 5, and a1 is 3, so this should be 3 plus 1, 4. This would be 3 minus 5 plus 2, so that would be 3 minus 5, negative 2 plus 2, so 0. This would be 0, and therefore we do not continue because one of the geometric terms would be 0, and third term divided by 0 would be definitely undefined. So we reject negative 5. We consider d equals 3. So having found the common difference is 3, the product therefore of the first term and the common difference of the arithmetic progression is 3 times 3, and that is 9. Then we have problem 10. Find the sum of the 20th and the 30th triangular numbers. The 20th or any triangular number is also the sum of the first n counting numbers, and it is n over 2 times quantity n plus 1. So therefore 20th, so 20 over 2, quantity 20 plus 1, then 30th plus 30 over 2 times 30 plus 1. So 20 over 2 times quantity 20 plus 1 plus 30 over 2 times quantity 30 plus 1, and that is equal to 210 plus 465. The sum is 675. Problem 11. Which of the following is a prime number? So first, let's divide 6,319 by all prime numbers from 3 except 5, of course, except 2, up to the lower value of the square root of 6,319, and we finally able to find the factors as 71 times 89, so it is not a prime number. B, we do the same thing. We divide this by all prime numbers from 3, of course, except 2 because it is obvious, not divisible, and 5 up to the lower value of the square root of 1 to 71, and we find the factors as 31 times 41, so that's not a prime number. C, 3611, we do the same thing, and we can factor that as 23 times 157. Then only D, where the factors are the number itself and 1. So we conclude that 1171 is the prime number. So the prime number is 1171. 12. Find the solution set of the inequality 5 over 2x minus 1 is less than x minus 2. So we rewrite this, transpose x minus 2 to the left. So 5 over 2x minus 1 plus 2 minus x should be less than equal to 0, or this should be negative. Simplifying by algebra, so 5 plus quantity 2 minus x times 2x minus 2x minus 1 times 2 minus x all over 2x minus 1 should be less than 0. So simplifying further, 5 plus 4x minus 2x squared minus 2 plus x over 2x minus 1 should be less than 0. Combining, so that would be 3 plus 5x minus 2x squared over 2x minus 1 less than 0. Then we factor the numerator into 3 minus x times 1 plus 2x over denominator 2x minus 1 less than 0. Then we get the sign of 3 minus x. X is 3. When x is 3, the value is 0. Then the sign, when x is greater than 3, let us say 10. So 3 minus 10 is negative, so negative here. Then when x is less than 3, like 0, so it is positive here. Positive, then negative to that case. 1 plus 2x, so when x is negative 1/2, it is 0 here. Then when x is greater than negative 1/2, like 0, so 1 is positive to the right of negative 1/2. Then when x is less than negative 1/2, like negative 10, 1 plus 2 times negative 10 is negative here, then positive beyond 1, negative 1/2. Then finally, we have 2x minus 1, so x is 1/2, positive 1/2. It is 0 when x is greater than 1/2, like 10, 2 times 10 minus 1 is positive 19, so definitely positive here. Then when x is less than 1/2, like 0, 0 minus 1 is negative 1, so negative in this part, positive there. Then we get the overall sign. So we go down. So positive times negative is negative divided by negative, because we have multiplication in the numerator. So it is positive in this interval. Then positive times positive is positive divided by negative, negative in this interval. Then positive times positive, positive over positive, so positive in that interval. Then finally, negative times positive, negative over positive, negative in that interval. So since this inequality suggests that this should be negative, so the solution set would be this and this interval. And we do not include 1/2, of course. It's already not included from the figure because the denominator will be 0 and it becomes undefined. So therefore, this is the solution set, open, then open 3 to positive infinity. So the solution set is open quantity negative 1/2, comma 1/2, close parenthesis, then union with 3, comma positive infinity. So it's letter A. 13. A silversmith wishes to obtain an alloy containing at least 72% silver and at most 75% silver. Determine the range of amounts of an 80% silver alloy that should be combined with a 65% silver alloy in order to have 30 grams of the required alloy. So we will call X as the amount of 80% silver to be combined with 65% silver alloy in order to have 30 grams. Therefore, we have 0.72 of 30 grams should be less than equal to or less than quantity 0.8 of X plus 0.65 of 30 minus X. So if the amount of 80% silver is X grams, the amount of the 65% silver alloy should be quantity 30 minus X, because the total mass should be 30 grams. And that should be less than 0.75 of 30. So 0.72 of 30 should be less than equal to 0.8 of X plus 0.65 of quantity 30 minus X, and should be less than equal to 0.75 of 30. Simplifying, 21.6 less than equal to 0.15x plus 19.5 less than equal to 22.5, where 0.15 is 0.8x minus 0.65x, and 0.15x and 0.65 then 30 is 19.5. Subtract 19.5 to all sides of the inequality. 21.6 minus 9.5 would be 2.1 less than equal to 0.15x less than equal to 22.5 minus 19.5 is 3. Finally, divided by 0.15, 2.1 over 0.15 is 14 grams less than equal to X less than equal to 3 over 0.15 is 20 grams. So therefore, the range of amounts of 80% silver alloy should be 14 grams to 20 grams. 14. What is the GCF of 72, 120, and 360? So the technique is we factor completely each, then we obtain the product of common factors with least exponent. So 72 is 24 times 3, or 2 cubed times 3 square, 8 times 9, so 2 cubed times 3 square. 120 is 12 times 10, so that's 2 squared times 3 times 2 times 5, so 2 cubed times 3 times 5, 120. Then 360 is 36 times 10, 2 squared times 3 squared times 2 times 5, so 2 cubed times 3 squared times 5. 2 cubed times 3 times 3 squared times 5. Therefore, 2 is common, 3 is common, 5 is not common. So for 2, the lowest is 2 cubed, and for 3, the lowest is 3. So the GCF is 2 cubed times 3, and 2 cubed times 3 is 24. And finally, find the second term of a harmonic progression if the seventh term is 1/2 and its 17th term is 1/5. So seventh term of harmonic progression is 1/2. Therefore, the seventh term of arithmetic progression, the reciprocal of that is 2. The 17th term is 1/5 of the harmonic progression. So the 17th term of the arithmetic progression is reciprocal of 1/5, so 5. And the formula from arithmetic progression is an equals a sub n plus quantity n minus m times common difference. A sub n equals A sub n plus quantity n minus m times d. So we use this data here. So 5 equals 2 plus quantity 17 minus 7 times d. Solving for d is 3/10. We then find the second term using the same formula. And I'll use 2 here. 7 second 7 minus 2 times d 3/10. So 7 equals second term of arithmetic progression plus quantity 7 minus 2 times common difference 3/10. The second term of the arithmetic progression therefore is 1/2. So the second term of the harmonic progression is the reciprocal of 1/2, which is 2. So that's it for this video.